Section 10.6, our objective today is I can describe the locus that satisfies a given condition. So first of all, let's define what we mean by locus. So locus is defined by a figure that is the set of all points and only those points that satisfy one or more conditions. In other words, it's describing or the description of the location of points that satisfy one or more conditions. Okay, so we're talking about describing where the points are that meet the condition. So for instance, if I have a point P in a plane, okay, and that's the key, that's in the plane, and I want the locus of all points 1 centimeter from P. Well, the first thing I do is I locate one point 1 centimeter from P. Okay, there's one. Then I say, well, are there others? Yeah, there's one there, one there, one there. Are there more? Okay. And so if we keep doing that, we will see that we will eventually get a circle. And so we would say the answer to this would be the locus of points 1 centimeter from P is a circle. With center P and radius of 1 centimeter. Okay, so it's very, very clear which points I'm talking about, and my description leaves no room for any other points. Now, what if I went from a plane and I went to space? So I still have point P, and I still want all the points 1 centimeter from P, but now I'm talking about in space. Okay, and so then if I'm in space, so this was in a plane, so it's really important to know what dimension you're working in. This is in space. So in space, the locus of points 1 centimeter from P is a sphere. So we would say the locus is a sphere with center P and radius of 1 centimeter. So that would be the answer to that question. Okay, so when you're working with locus, there are basically 3 guidelines that you want to follow. Number 1, be sure of what dimension you are working in. Okay? If it doesn't say, then you assume space. Okay? Number 2, locate at least some points that meet the condition. And number 3, then the actual answer comes from describing the pattern of the points. Okay, so, for instance, example. So, what is the locus of points equidistant from the sides of a triangle? Well, if we have a triangle, we know that the angle bisectors are equidistant from the sides of each angle. And so the locus of points equidistant from the sides of the triangle is going to be the intersection of the angle bisectors. So the answer is the intersection of the angle bisectors is the locus of points equidistant from the sides of a triangle. Okay? Okay, so let's look at this example, example 2. Okay? If I have a line J and a parallel line K, okay, what is the locus of points equidistant from J and K? Well, here's a point exactly halfway between. Here's one, here's one, here's one, here's one. Okay, so we're working in a plane because lines are in a plane. And so we see then that the red line would be the locus of points equidistant from J and K in a plane. And so we need to describe that. So if we describe that, we would say the locus of points equidistant from J and K is a line parallel to J and K and halfway between them. Okay. So that's in a plane, but what if I said, what is the locus of points equidistant from parallel planes? So if I have this plane and this plane, okay, well, now I'm talking about space, and so what's going to be equidistant from those two planes is another plane, again, halfway between and parallel to. Okay, so this is space, because now we're talking about planes. So if I have two parallel planes, so plane J and plane K, then the locus of points equidistant from plane J and K would be a plane parallel to J and K and halfway between them. Okay? Okay? So given a segment in a plane, what is the locus of points equidistant from x and y? Well, we know from our constructions that the points equidistant from x and y are the points on the perpendicular bisector. Okay, and so the points equidistant from x and y would be described as the locus of points equidistant from A and B is the perpendicular bisector of segment AB. So in other words, the whole idea here is describing. Let's do one more example. Okay, so in space, okay, I have a line. In space, what is the locus of points equidistant from line L? So we'll call this line L. Okay, well, there would be here and here, but that's just on a plane. So if you picture this turning, okay, so that kind of looks like a pipe or a cylinder. So we'd say the locus of points equidistant from line L in space is a cylinder with L as its center.